The following video shows the process of my bachelor's thesis in landscape architecture, specializing in BIM. The work started with a project search using architecture competition sites such as Espazium. The goal of the bachelor's thesis was to create a model-based implementation plan combining civil engineering and structural engineering models. After deciding on the project to redesign the Interlaken-Unterseen Golf Club, the analysis phase begins with a site inspection. On site, a picture of the perimeter and the problems and constraints, as well as potential goals of the client, are discussed. The project includes a complete redesign of the inner courtyard, the terrace and, as the main area, the car park, and subsequently the surrounding terrain. At the beginning of the analysis phase, geodata is searched for important information and special conditions. Analyses that have been made are, for example, the number of visitors to the golf course and the utilization of the existing car park, the existing drainage and its utilization, as well as movement zones of the visitors with the most frequently chosen paths. From the analyzed topics and the needs and demands of the client, conceptual topics are formed that are considered the foundation for further planning. Conceptual topics are the parking innovation. Innovative parking areas are designed that are close to nature and allow a large part of the precipitation water to drain on site. Durability and high quality play a key role here. A further topic is the enhancement of the golf club's image through prestigious design. The golf club is one of the leading golf courses of Switzerland, which places a certain demand on the quality of the infrastructure. High-quality materials, in combination with an aesthetical design, lead to this effect. The newly created spaces should be flexible, multifunctional, and open. The spaces should invite people to spend time before and after their round of golf in them. In the preliminary project, the conceptual topics are transformed into a realizable design. Important issues in the planning were above all the utilization of the car park. A minimum number of 140 parking spaces had to be created. Civil 3D plugins, such as vehicle tracking, were used here, which make it possible to have different kinds of vehicles drive through the newly planned space, revealing bottlenecks and problems. The grading optimization plugin enables the best possible site grading to be built up on a conceptual level, with the cut and fill values as balanced as possible. The plugin helped to understand the perimeter in relation to the terrain modeling and to find optimal gradient directions in the perimeter. After the preliminary design, an executable civil engineering model was created in Civil 3D. The pavements to be constructed were built up and parameterized together with the layers. Each layer is built up by its own DTM. This enables an exact quantity determination with little deviation. The existing and planned pipes were drawn in and planned with the Civil Pipe Network tool. This results in a BIM-compliant pipe planning in the civil engineering model, which is enormously important for the eventual execution. The Civil Project Explorer, as the third plugin, enables an exact quantity determination, which is indispensable in the later cost estimation. The intersection between Civil and Revit is closed by two further plugins. Speckle, as a 3D data exchange platform, enables civil pipes to be sent to the Revit model via the cloud. In Revit, the data can be received again through the speckle connector. Unfortunately, the pipes can only be received as a mesh. The developer's goal is to receive the pipes as a Revit pipe family. The developers are currently still working on this use case. This function can greatly reduce the planning effort for the pipes in future projects. In this bachelor thesis, the pipes in the Revit structural engineering model were also created as Revit pipe families due to the unsightly representation of the mesh civil pipelines. The topographies created in the civil model are transferred via Autodesk Construction Cloud to the Revit model, where they are built up as floor slabs with the appropriate layer thicknesses and materials using a Dynamo script. In the Revit building model, fittings, lighting plans, and visualizations are made. This is where the Enscape plugin comes into its own. The plugin makes it possible to create photorealistic visualizations in a short time. The plugin also offers the possibility of viewing the project in detail via VR glasses. This enables you to get a good picture of the planned lighting situation. The cost estimate is based on a combination of quantities from both models: the Civil Project Explorer for quantity statements of the civil engineering model and per component list in the structural engineering model. In line with the innovative aspect of this bachelor thesis, the two executable models are delivered completely digitally via Autodesk Construction Cloud, which acts as a single source of truth in a common data environment, CDE. Finally, I like to peek into the future and give the audience the keywords Autodesk Forma and Autodesk Industry Clouds on their way. As a guiding quote for my work, I can adopt the words of Autodesk CEO Andrew Anagnost: "Today's disruption, tomorrow's transformation."